Hi everyone present in this live stream. Before we move on to the actual session, I would just like to thank our event sponsor Salesforce, our diamond sponsor Zoho and VMware, our platinum sponsor CrowdStrike, our gold sponsor Cred, and our silver sponsors Kyanamurga Technologies and HNR Block for the help and support in making this huge event possible for students all over India.
Hello everyone again. Welcome to the second day of Introduction to Binary Exploitation. I'm Nikhil, and Aditya is going to join us to explain all the stuff that was left to be explained yesterday. Okay. So we meet again. So where were we? We were discussing buffer overflows, and we discussed this simple challenge, which on analyzing this challenge, we see there is an auth variable which is initialized to 0. There is a paraphrase. We are supposed to enter a paraphrase, and we are using this getS function. So if we have watched yesterday's session, we know that getS is said to be a very dangerous function, and it should not be used as it takes no limit on the amount of characters to be read. So imagine passphrase takes 20 characters, which is written here, 20 characters. So getS, what it does is it would ignore the limit, which is 20 right now, and it will allow the user to input as many characters as it wants. So this is an obvious vulnerability because the user may input as many characters as possible and override the return pointer. If you don't know what a return pointer is, please watch the previous day session. A return pointer is the pointer to which the function will be returning after once it gets executed. So the return pointer, using the getS function, an attacker can override the return pointer. The next thing we see is if auth. If auth here, it means if auth is not equal to 0. So obviously on the second line of the code, we see that auth is equal to 0. And here we are checking if auth is not equal to 0. And in between these two lines, there is nothing specific. There is nothing written about auth, right? So auth is 0 here. When the control comes in this if statement, auth is 0 here. So this statement will never be true. It will always go to the else part, and we will always get access denied. So how we will grant the access? How we will gain the access? So here, when we are inputting a passphrase using the vulnerability of the getS function, we will cause an overflow, buffer overflow. Okay. So what is a buffer overflow? What is a buffer? Everything was discussed yesterday, and yeah. So what we do is we input as many characters in this passphrase. You can see this in the stack, this passphrase, so that the stack gets filled up and reaches the place where auth is. What's our auth? Auth is 0, which was assigned here, and reaches the place where auth is. Just because using the getS vulnerability, we can override the values on the stack. We override the values on the stack. The value of auth inside the stack gets changed, and depending upon your input, on what you input to getS, it will be changed an auth. We will be doing a hands-on practical example on this later on, but this is overall a recap of buffer overflow. So what to do next? How do we actually write an exploit? How do we take advantage of this vulnerability, as we can say? And yeah, so contours. We all know Python is a really strong programming language, and Aditya will be explaining about contours.
So we can just imagine contours as this, extra library that we are using to use the functions in that particular library. So in case of if you're familiar with C program, you have hash include. That's basically we have calling all the functions which is defined that particular library. So here contours is a library as such. So in CTFs, and especially for CTFs, contours is being curated, where it is a CTF framework and an exploit development library. It is a library in Python that helps one interact with the ELF files. So yesterday we learned about ELF files as such, which is basically binary. So you know in binary we have to give input, like yesterday I showed you buffer overflow on the terminal, where it asks for a particular enter passphrase as such. So for that we were giving input 1111 but 20 times. So if you use pawn tools, we don't exactly have to run the binary by manually and to give the input manually as say. We could just simply use pawn tools and you could just simply script it up and just run that particular script and yep, you can interact with the ELF file which is given. But the question comes, why do we need pawn tools? Why do you want a pawn tools to interact per se? So the main reason is that you can other without pawn tools also we can interact with the ELFs. So we'll see the why part of this particular question later onwards when we show you red to win. For the time being, always remember that you just have this why question in this slide which we are skipping. So next is how to install pawn tools. So these are the particular commands which are being used to install pawn tools, and this commands is basically reserved for Linux library, so the Linux systems. So that's it. Next is how to use pawn tools. So like I said in the C programs, we could have the thing called hash include where we are calling that particular library for using. So in terms of like Python, there's this thing called from pawn import start. So from statement is basically we are like from say X, from X. So X is the name of the library and from is basically we are calling upon that particular library, and import star. Import star basically means that we are calling every single function which is defined in that particular library. So if I were to give from pawn import and a particular function name, then I can only use that particular function in our program. So if you use star, we are calling the every single function and everything which is defined in that particular library. So next is basic understanding of how we use this. So even though I'm giving you the theory part over here, you would have a better understanding of it later onwards when we are actually showing you how to script and exploit. But for time being, always remember that whatever I'm telling you is just theory and you just have to recollect it when we are doing the hands-on. So first of all, we have to connect our particular exploit that we are writing to these the ELF file. So for that, we're using IO is equal to process of ./ELF file. So that's just the name of your file. So when you do this particular statement, we are basically running the ELF file. So we generally have to, like we showed yesterday, we have to do / of your file name to run a particular binary. So over here, what we do is that we're using the same thing, but we're giving it to the particular variable IO. So this IO, whenever you use this IO later onwards, it's basically you have run that particular binary. Next is IO equal to remote, which is basically we are connecting to a different server. So connected to a server, if you guys are familiar with NC commands, so NC is basically used to connect to a particular server and particular address, IP address, and also the port. So we're using remote I is equal to remote of IP address to connect to and also comma port. This is the format of how you can connect to a particular server. Next up, we have receiving data. So again, as I said, just understand this. We'll be showing you hands-on, you'll understand better. So receiving data as such, if you use a function called receive of n, receive e of n. So if in the before slides, we showed you that IO is equal to process of / your file name. So basically, I told you that when you do process of your file name, you're storing that in IO. So whenever we want to give any sort of you have to get any sort of information that the binary is going to send you. For example, last time I showed you the buffer overflow challenge, there was a statement called enter passphrase. So that is something that the program is giving you. It's shown on your terminal per se. So that is a particular data that the binary is giving you. So if you want to receive that data, so that is when we use the receiving, all these receiving functions which is right there on the screen right now. So receive of n is basically, n is the number of bytes which we have to receive. Let's say we give receive of 2. So you can only receive the 2 bytes from from how many of a byte that the program is giving you. So receive is the function which is there in the pawn tools, the pawn library. Next is the receive line. The receive line is basically you'll get all the things that the program is sending you until a new line is encountered. So basically, if there is the program is sending you hello and the next line hi. So if you do receive line, we basically will only get hello because we just give what is there until a new line is encountered. Next is receive until a delimiter. So a delimiter basically means you could just refer to as a percentage or a percentage or a hash or any sort of those kind of special characters. So what it does is that let's say there's a hello and there is a hi in the next line and then there is a namaste with a percentage. So if we give receive until percentage, what it does is that it receives every input, every statement that the program is giving you until it encounters that percentage. So that is what receive until delimiter gives. And like the example that I said was of a percentage. So if the program is again giving you like a hi, hello, namaste, percentage, if we give it receive until of percentage, we will get all the data that the particular program is giving you until that percentage. And other than these three functions in case of receiving data, there are more of it and you can find those in the official documentation of pawn tools. Next is sending data. So as I told you last time when I showed you the buffer overflow challenge, there was this thing called enter passphrase that was receiving of data. But afterwards, I was giving around 20 once. So that is me sending data or giving an input to the particular program. You could automate the process by using the functions in the pawn tools, and the functions are send data. So send data, what it does is that whatever data you want to send should be inside that two parentheses, and then just send data as such. So it just sends the data to the program. So next is send line data. It's that it sends the data plus a new line also. And next is send line after. So what send line after does is that, like I said before, using the same example again, enter passphrase colon was what the buffer overflow challenge was giving us. So if I write send line after in the inverted commas, if I write passphrase colon comma 1111 20 times, what it does is that it only gives the data that the 111 into 20 times only when it encounters a particular phrase, which is a passphrase of colon. So let's say like I said before, the example, hi, hello, namaste, and percentage. So what it does is that if I give send line after and a namaste percentage, then only when it encounters a namaste percentage will it send the data that I'm giving as an input. So that is what the send line after is used for. So there is three, we are mentioning right now, three send functions. So after that, we have another important function called io.interact. So io.interactive, what it does is that, it leaves the shell open for us to interact further. So like I said before, we exploit majorly not on our server. We do it locally, but we do it remotely in the other person's server. So if I finally exploited the other person's server, I would want to make sure that I can still access the shell that I exploited. So for that, we're using io.interactive, and we will show you this io.interactive interactively in the hands-on session. Next is Gdb Dot Attach. So as you guys know, hopefully you guys know Gdb, which is basically one of the GNU decompiler per se. And we're using that in order to analyze all those, analyze the binary which is given to us. So Gdb Dot Attach, basically what it does is that, let's say we are receiving data, we are giving input, but we want to analyze the binary as such. We want to analyze the addresses, or we want to get into the binary, or you want to see how the value stored in one register changes when certain things that we give happens. So for that, we use Gdb Dot Attach. It creates a new terminal window with Gdb attached to a binary, which is run by pawn tools. Next. So this is a very sample program, pawn tools program we have. So this is the format. From pawn import star is basically how we call the pawn tools library. And IO is equal to process of sh is basically we are running sh. The binary named sh, we are running it. And that has been stored in the IO variable. And IO.sendLine is basically we are sending echo hello world to that particular program, that which is sh over here. And IO.receiveLine is basically we're receiving whatever the program is going to give us after we have sent the line echo of hello. So right now we will be showing the buffer overflow challenge to you.
From Traboda, just change me. Yeah. So first of all, we want you all to look at this source code and understand what change me actually is about. Okay. Okay. We want you all to look at this. So here we have a set vbuff. So we want you to wonder what a set vbuff does. So basically, a set vbuff in C library function defines how a stream should be buffered. Okay. We told you what a buffer is. So this set vbuff is not really a concern for us in binary exploitation. So in buffer overflow challenges, the main concern is after that. It's int override. In override me, the variable is initialized as 0, and there is a buffer variable which is allocated 32 bytes, and then we are inputting that buffer variable using gets. As I told you, the gets function, vulnerability again. The function is really bad again. So what this function does is, I'll say it again, key. It doesn't have the limit of how many bytes that you can enter. Okay. So after that, what it checks is that overwrite me, which was supposed to be 0 and is 0 while entering the if function, is checked by the if function, if thing, whether it is 0x1234 or not. Obviously, when the program runs and when the control reaches the if statement, we see that the overwrite me is 0, and it won't pass the if statement. It will go to the else part, and it will give us the statement that sorry folks, you will still have to work your way up. So what can we do with this program? How can we enter the if statement? And after entering the if statement, we get an execv bin sh. And what is execv bin sh? Execv bin sh is something. How can we explore that? It spawns a shell for us because it has bin sh as its parameters. Okay. So what execv does is it executes the program referred to by the path name. What's the path name here? Path name is bin sh. It will execute what is there inside the path name. Okay. This causes a program that is currently being run. This program is currently being run by the calling process to be replaced by a new program. The new program would be ./bin sh, which is a sh file, shell file. So basically, it means here a shell will be spawned. Your aim of exploitation is fulfilled, and you'll be getting a shell if you are able to get overwrite me turned from 0 to 0x1234. Now let's see how do we do it. Okay. We open a terminal. I hope you all can see my terminal. Change me. So we have a challenge file. Let's open the challenge file in Gdb. Okay, Gdb shall. So before going to the debugging section, what a person does is it will review what is already there provided to us. So we will be reviewing what is already there. The functions are already there to be disassembled by us. Right? We'll just to know what functions are there in this binary, what functions are there in the C program. We will type info functions in the GDB. Okay, it's Chef. Chef is an extension, by the way. It's a really cool extension. You can also switch into that once you are familiar with pointing and all. So info functions. So these are the functions which are already present inside a binary. For this time's sake, you don't need to worry what all these things are. We'll be focusing on the main function. Okay. So how do we look into the C code? How do we look into the assembly code of the main function? It's simple. Disassemble or disas main, or the address we can use, or the address here. But for simplicity's sake, we'll be writing this as main, and we see the assembly code of the main function. So what are we seeing here? It's simply the code that we had, here, converted into a machine code, a code close to the machine code, which can be understood by us, which is assembly, x86 assembly, that we have been learning since last 3 days. Okay, so this is assembly code. So what this assembly code is, I wanted to know to identify the vulnerability here, which is getS. Now we find a call to the getS function. Okay, so for the past 3 days, the 2 RE sessions, the 1 pawn session you always been learning what is the calling convention of a function in an x86 architecture, 32-bit architecture. So what comes in your mind? Yeah, we push things on the stack. The arguments are pushed on the stack. Okay, so here getS, before calling getS, we see that something gets pushed on the stack, which is EAX, and before that EAX function, the address of the EAX function is referred to EBP minus 0x2c. So what is EBP minus 0x2c? Okay, to find that out, let's try to run the program in GDB. Before running the program, we'll set a breakpoint after getS function, or anywhere that you want, basically. So we'll set a breakpoint here after getS function. We'll run the program. Okay, and I don't know how many bytes does it take, but let's provide 4 A's, 4 B's, 4 C's, 4 D's, anything. Let's provide 4 A's, 1, 2, 3, 4 A's. And it hits the breakpoint because we set the breakpoint at this line. It hits the breakpoint here at this line, this very same line. Now let's analyze where our A is. Okay, where our A is stored, on which register our A is stored. Where is A stored on the stack? So while analyzing the assembly code, we can see something gets pushed on the stack, and that call thing getS, the value that we are going to that we were going to input, gets stored in EAX. Okay, so that EAX is being referred to EBP minus 0x2c. So what's EBP minus 0x2c? Okay, so theoretically, our input should be there in EBP minus 0x2c because it's there in EAX. Then we are pushing EAX on the stack, and then we are calling getS. So it basically means getS bracket EAX, which what was the variable? I don't remember, but buff. Yeah, getS buff is EBP minus 0x2c. So what do we do? x/s. S means the string. Okay, $, the register, EBP minus 0x2c. What should give? It should give a 4 A's. So yeah, our input is there on EBP minus 0x2c when the control is here, when the control is in this statement. Okay, because we put a breakpoint there. So what does it do after that? It compares the 0x2c with 0x1234. Okay, 0x1234. So on the last buffer overflow challenge that we saw, it wasn't comparing anything, it was just comparing whether it is 0 or not. So if it is not 0, then only we'll be able to override. Then only we can grant. We have the access granted. But here in this program, this binary, things doesn't work like that. 0, it should be equal to 0x1234, as we can see in the code. It should be equal to 0x1234. Then only we can execute then only we can spawn a shell. Then only the binary will get spawned. So what we can do is, you see that the buffer is already 32. Okay, so let's write a simple pawn tool script that we've been learning since the past 20 minutes from now. So let's write a simple pawn tool script of this challenge. Okay. Yeah. Select it. And so nano expt.py. I have already have a expt here. So first line of your pawn tool script is gonna import the pawn library. Okay, so from pawn, it's importing pawn, the library, pawn library. Import all the functions inside the pawn library. Star means that. Then we are creating a process of a binary, which is p is equals to process of dot slash in brackets in inverted commas, sorry, dot slash chal, name of the challenge. Okay, name of the binary. Okay, what we do after that is start creating a payload. Okay, so payload
is basically what we are giving as input
what
to the program.
The constructed input that we are supposed to give to a vulnerable program so that we can take advantage of it. We can call it payload, you can call a constructed input, you can call it anything, okay, as you wish. It sounds cool, like a payload. So we're giving a just because 32 ways, okay. Sorry, 32 ways plus p32. So this function, you must be wondering what is a p32 function, and I'm sure if you're never ever done binary exploitation, you've never ever heard about this p32 function. So this is a 32-bit binary. Just let me go back and explain. File chat. We taught you yesterday also how to check what kind of binary is you have on the system. So file shall, we have a 32-bit binary. Yeah. So yeah. So for 32-bit, we'll be doing a P32. If it's a 64-bit, we'll be doing a P64. So what it does is it packs the addresses in such a way that the architecture, it's a 32-bit architecture. It supports that architecture. So 0x1234 here. We just can't send it like that, okay, without the P32. It needs to be sent in a proper manner. We taught you what is big Indian is, what is little Indian is. So it needs to be sent in a little Indian format. Only that, then it can be read as read on the stack. Otherwise, our payload won't work, our exploit won't work. Okay. If you have any doubts regarding this, please ask it on the chat box, and we would be really happy to clear that out. So P32. So it looks like. And then we go here. And then we add the send. We need to send the payload to the binary, right? We need to send the payload to the binary. Then we'll just send p. And after that, after sending the payload, we want our shell, which will get executed after the if function gets to be open for us. Sorry, to do things. Okay. So p dot interactive. One that Aditya said. Interactive. Okay. So this is more or less supposed to be an exploit, and let's see now whether it works or not. Even I'm not sure. Okay. Python 3 exp.py. So much. Oh, it's not. It's not. Okay. So what the problem here is? So we can't concat. We can only concatenate str to str, not bytes. Okay. So what we do is, this a into 32 are supposed to be converted to bytes, and it is not here because it's string here. Okay, str, a string. So what we do is we convert this.
If you're working on Python 2, we don't have to do this particular, putting a B before.
Python 3 is something else. It's not something else, but it has some limitations for us exploiters. So we just add a B. What B does is basically turns the strings here to bytes. 32 is as bytes into a payload plus P32, which also returns the value as bytes only, 0x1234 as bytes. Okay, so 0, yes, okay, save it. Python 3 xpp.py. Okay. Should run an exploit. So now we have a shell, and if we see that, we can play with it. We can say who am I. Night King is my name in this PC. So we have a shell spawned here. So this was a really simple exploit for you all to understand. So yeah, let's go back to the slides. Change. And now we want you all to ask us the doubts that you are having.
One of the major reasons we were able to get the shell was because this is what XFV does. So because there's XFV line is there after the if overwrite me, that's why we were able to get the shell. Shell basically means, if you could remember what Nikhil showed in this terminal, there used to be a folder which he went, right? So once we get a shell, we get access to anything which is there in that folder. So consider a shell like that. So if we put the interactive io.interactive, we are getting hold of the shell using the exploit, but afterwards we are keeping the shell alive using io.interactive.
So someone just asked, how do we do P32? You don't need to worry how do we do P32. P32 is just a normal function inside Pontools library. If you don't know what a Python library is, it's just I know, a bank of really cool functions, really cool stuff. We can take our tools out of it and work with it. We exploiters can take a tools out of it and work with it. That's why the name Pontools, I guess, I don't know. But yeah, P32 is a function in Pontools. How to send in a little Indian format. Sending in a little Indian format, P32 does everything that needs to be done while sending it in a 32-bit binary, whereas P64 does everything what needs to be done in a 64-bit binary. There is no need for you to worry about how do we send a little Indian format. For you to know, we have a simple thing. You must be wondering, was exploitation there without Pontools? So there's one thing that I can show you now. Let me show you. Go to the document. Without Pontools, what people usually used to do is they wrote their exploit, and after writing the exploit, they used to pipe that output of the exploit inside a file, and while running the vulnerable binary, they used that file from which we got the Python output as an input. That's a really long and really confusing statement for you all to understand. I'll repeat it again. Before Pontools, if we are not linking a binary to exploit, okay, we are writing a Python script, and the output Python script, which is our exploit, which is going to be a constructed input. Okay, which is going to be a constructed input. That constructed input is gonna send, is gonna stored inside another file. Sorry, understand, like output. Okay. Another file called output. Now that output file should be the input file of the binary, which, because that output file has the constructed input that we're gonna construct using Python. Okay. So the I don't know the basic syntax of creating a normal buffer overflow exploit without pawn tools would be Python C print a into, like, we can say 32. I'm not writing the exploit here, right? Okay, now and then plus, if we are entering in a little Indian format, then we have to give something like b backslash x 0 it was 1 2 3 4, right? So 3 4 backslash x 1 2 this. Okay. After that, just pipe our input to an input file. Okay. Now this input file that will be created here, okay, will be the input file that we're gonna supposed to give to the binary, because it has a constructed input, but we're not gonna do it right because okay. So we'll be moving on to the next challenge, which is a read to win function. So have you ever wondered, what if our there is not an if function here, there's another separate function. If statement here, there's another separate function which has a shell. So we can't override the variable here. We need to jump to another separate function which has an execute shell, which is the read to win.
The major point of CTFs is that we need to get the flag or we need to get a shell. So right now, the previous challenge, slide before. In the previous challenge over here, if you could see, the XCC was present in that if loop. So what I want as a CTF player is to get a flag, and to get the flag, I like I said, I either need a flag which is present in this particular folder, or they should just print out the flag to me when I get it, when I exploit. So in this particular one, we are getting a particular shell, right? So what if this entire program that you're seeing, it is structured in such a way that the if loop is inside another function. So that is what read to win does. So what happened over here is just a normal variable override. Like before, I've shown you, in the slides. Can you go up with the slides? Up.
What up?
Buffer overflow.
Oh, okay. This one.
Okay, this one. So when you see here, what happened till now that we done with this program and also the variable override program is that we used our input in such a way that we could change the value of the nearby local variables. So when you look at this program over here, passphrase, we're giving our input, the 20 bytes, and that is there in the gets passphrase. We are giving the input through gets passphrase. So we're giving 20 bytes, then the whatever input that we are giving would get stored in that particular passphrase. But what if we give 21? The 21 will be stored, the 21st that element will be stored into the auth, right? So if you look at the stack as such, you could see that there is, look at the bottom, from there the passphrase, there are 20 bytes being 20 space, region being saved for passphrase as such. And afterwards there is auth. which is another local variable. And after that, there is RBP, which is basically the base pointer of the stack. Like I said before in yesterday's session, if you have a table, if you want to create a particular stack, RBP is just the base pointer or the first book that you're keeping on the table. And after that is the RIP. So what exactly is the RIP? Yesterday, I'll give you a small example of how if you want to go to a particular restaurant and you have no clue of how to reach there after a particular junction, that junction is the RIP. It is basically points you to in context with the actual definition per se of RIP. It is basically what makes us go to the particular place if you are supposed to go after execution of a function. Okay, so in yesterday's slides which I showed you, we gave that function 1, inside that function 2 is called, after that function 3 is called. So once the function 3 gets over, how does the stack know, how does the program know that it has to go to function 2? Because the function 3 is right now over. So that knowledge is given in RIP. So RIP contains the address to which we have to go once once the function is over, or once we have finished calling the function. So the red to win program.
Everybody understood what RIP does? That was a great explanation.
So right now over here, if you look at it, there is a main function, and inside that first sight, you should be able to identify the buffer, which is char buff of 24. That is the buffer over here. And afterwards, a gets function is called, a gets of buff. So that we know that we can give an input also. So that is what we have been doing all this while. But the funny thing over here is that the XSV is there in another function called int_win. So we somehow has to reach there. But if you normally execute the program, you'll never reach the win function, because that's not how the program works. Normally, if you just check it, if you normally execute this particular C program, you're just gonna get a printf statement, and then afterwards a gets comes. So when a gets comes, what we do? We give our input and just go tata bye bye. That's it. It's good. So how do you reach that win function? How do you go to that win function? Because what is so special about win function? XSV is there. XSV is the shell. So from the shell, we could get the flag. So that's why we want to go to the win function per se. So now to reach there, you know that buff has 24 bytes input. Like you can give 24 bytes and buff is happy, content with life. But what if you give 21? What if you give 22? What happens? Earlier, there used to be a variable before it. Like in case of passphrase, char passphrase 20, and before it, there was this thing called int auth equal to 0. So what if there isn't a variable above it? So we are not overwriting a variable. So we are given 21, so where would it go? So in the stack, if you examine the stack, it would go to the RBP. Okay, so you are going to fill the buffer with 24 bytes, and then we are going to fill the RBP. So once you fill both of it, next we reach the RIP per se. So can you go to the slide showing the RBP?
Sure.
So here, so what we have right now is a char buff of 24 size, and we don't have this auth. So just completely erase this auth which is there in the middle. So we just have a char buff of 24 size, and after that we have an RBP and then RIP. So this is how a stack frame is structured. So we should do in such a way that we need to fill the char buff of 24 bytes, and then we should fill the RBP also, and then we should reach through the RIP. So what does RIP does? Whatever address that we give in the RIP, the program takes us to that address. So if we give the address of the win function, then the program takes us to that particular win function. So that is what RIP does. So we'll now examine the entire program in Gdb to give you a better understanding of how this happens in a stack.
Till now, if anyone has any doubts, please put that in the chat. Okay. We'll be answering some doubts. Prabhat Pandey asked something. How do you all find the flag?
And where
is the flag?
So,
Hmm.
like if
Good
you
question.
could, like, Nikhil, go to the terminal and show the program which we solved, like last.
Shall I run the exploit?
Yes. So here, what we have, he run that there was this particular CTF challenge, and he run that exploit to exploit the challenge, and he has right now successfully exploited it. So what is his $sign over here? So that is basically the shell. Okay. So can you do an ls? See, in basically shell, in the sense, we are right now, we have access to that particular folder that he has. Okay, so there is, in that folder there are like 5 files: chal, core, exp.py, expp.py, and sample. Okay, exit.
Okay, so what if I want to open up core? Okay, so I'll just do cat. There's nothing in there.
Cat
Obviously.
XSP.
So cat means it will open the open thing which is there inside our directory. What if you want to see an exploit here? Cat expp. You can see an exploit here. So similarly, your flag will be there on the directory of the binary of the net of the remote server that you will be exploiting. It will be present there. Okay.
Can you show the
So you just
contents
have to
in your
do
directory now?
contents in the directory. You just
No,
have to do
not this.
cat
In your normal directory.
normal directory.
Quit this and go to the normal directory.
Yes.
Do an ls there. Show both of it together. So if you look at it over here, when the program was running, there was an ls, right? When he did an ls, he got the chal core exp.py, and right now he did the ls for his directory, the directory which is he is there in. So he got the same thing. So do you guys understand what is happening right now? If you, I exploited that particular program well enough that I got a shell in the sense, right now I got access to this particular folder that he is working on, or that program is present in. So right now in his system, he is himself pawning himself, like he is himself exploiting the program which is there. So he got control of a directory which he already has. So what if this particular program was in my shell, it was in my laptop? So if he was able to pawn my laptop or exploit my laptop, he would get control over the folder which is there in my laptop. So that is what exploitation basically is. So generally what we have is that when you reach to this level, when you do an ls, you would see a flag.txt. So if you cat the flag.txt, you would get a flag. So that is what generally what happens. So if you could just create a flag.txt and show them with a random flag. So that is what exactly happens. Flag.
CTFj, your genius.
On trainings.
Simple. That is it. Now if we do an ls, we can find a flag.txt. So let me tell you the difference between this process thing here and the things that we saw in the slides. Yeah, let me see where was it. So the ones that we did is running a binary in our own local host or local device, which is local device, and running the binary is like this. IO is equals to process.elf file, the elf file which is chal. So what if I want to run the binary on your computer? Okay, so I'll have an remote IP address of your PC. I'll have the port number, and so I'll connect to the IP address and to the port number using this using this function, using the function IO is equals to remote. Okay, So now imagine if I gain access to your computer shell, your device's shell, what all things I can do? I can obviously hack into your computer and access to things to which I'm not supposed to access, but that's a very unethical way of hacking. Okay, we are not encouraging that. We should never encourage that. So that's the main aim of binary exploitation. That's the main aim of CTFs. We hack, we get into the another's remote system and get the flag out of it. We catch the flag out of it. That is capture the flag, capturing the flag out of another server, another computer.
So there was this one doubt. Whether we could explain RIP once again.
Can you explain RIP once again? Okay.
Right.
So let me go. Okay. Swati, look. We have a passphrase here in the stack. I hope that you're having a basic understanding of what a stack is. Okay. So when we give a large amount of input, just because we have gets as the vulnerability here, okay, we'll be giving a large amount of inputs. It won't. There is no control of the amount of inputs that we are going to give. So it will fill the stack where once it will fill the stack till we reach auth, and after that, if we continue giving the inputs, it will keep filling it to here. So just a minute. To here, then to here, then to here, then it will reach the RBP, which is the base pointer. So if we keep filling it, because gets has no limitations, absolutely no limitations. We can input 1,000 bytes, even if the limit is 1 or 2. That's why you should not ever use this function. So the stack gets filled till RBP and RIP. It will override the RBP, then it will override the RIP. So you're asking what is an RIP? Suppose you're really tired from work, you're very tired from school, and you enter a home. So when you enter a home, you enter a living room. After entering the living room, you're really tired. You want to go to your bedroom. Go to your bedroom or go to a bathroom, be fresh. So you know what you're gonna do after entering your house. So whether a bedroom or the dining room or the bathroom or the kitchen. So a C program also works like that. After a function gets executed, it knows where it has to go. It has to go to another function, or whether it has to leave, whether it has to terminate the function. So what if the address of the another function is overwritten by us, okay, is controlled by us? So basically means that you're entering a home. So you were supposed to go to your bedroom after entering your home, but since we have exploited your mind, which in this case is computer, your RIP is controlled by us. The return pointer is controlled by us. We can take you anywhere we can want. We can take you to the kitchen. We can take you to the balcony, etc. So the RIP contains the address of the function. What is the address of the function? Let me show you in this. GD. This is the address of the main function. This thing is the address of the main function. Okay. So the RIP, we can if we control the return address of a function. This address of the main function cannot control the return address of the main function for now. But in the RIP, if we control the return address of the function that we just control the RIP, we can return to any function that we want, which is a win function on the next example that we're going to show you. Next example that we show you, sorry. This example, this is a win function. There is no win function called here. Okay. So after gets executed, we will be overwriting the RIP with the address of the win function. Okay, win function here. So what it does is when the RIP gets pushed onto the stack, it will execute the address of the win function just because we exploited it using getS. So I want Swati to tell whether she understood or not. We'll be doing the demo of this challenge now. Okay. Rishit here says why we use GDB. GDB is a debugger. So without a debugger, you won't be able to look into the assembly code because you won't be provided the source C files, C source code every time. You can be only provided with the binary, and you have to work with that. You can be only provided with the. So if you have the binary, you don't have the C code, then how will you know what is happening inside the binary? So you'll have to debug it. You'll have to see what it is doing. Okay, that's it. What's the next challenge? Box challenge. So it has a BOF, it has a C file, the C file you can see, but add BOF. See, it is the same file that we showed you. The win function and main function. Ignore the set VBUF part for now. Okay. So we can see, we'll see what type of file a BOF is. Okay. File BOF. So 64-bit LSB executable. So we looked into what 32-bit was. So we'll be now looking on what a 64, how we can write exploit of a 64-bit normal buffer or read to win challenge binary. So let's do nano. So we'll just analyze the binary using GDB. Okay. Let's see, we wanna take control from screen. This has. So what I told you, after looking into a binary, first you will like to know what kind of functions are there inside the binary. So you'll do info functions, info functions. Let's see what function do we have. So again, these functions you don't need to worry about right now. Okay. We have a win function, initialize function, which had the set VBUF part, which is also supposed to be ignored by you all right now. It's just to set the buffer, set VBUF. Okay. And there's a main function. Okay. So let's see what is there in the win function. Sorry, in the main function. Okay. First, we look into the main function because control starts, execution starts from the main function of any programming language. So the function calling convention push RVP move RVP RSP. As you all know, we taught you, we have been teaching you about this since the last 3 days. So this should not be, this should be a cakewalk for you all right now. Understanding what push RVP move RVP RSP is. Okay, even if you don't understand, just know that the RVP is a base pointer, and we are equating the base pointer and the stack pointer, which is which points to the top of the stack, at the same, because the stack is empty right now. Okay. After that, we'll call the initialize function, which had that buffer, setting the buffer wala part. And after that, we'll call a puts. What the call puts is, let's see what it brings. So we'll just take this address, and let's say x/s. Yes. It prints send it to me then. What is send it to me then? Where is send it to me then? Send it to me then. Yeah. So the next function that we're gonna execute is buff. It's guess. It gets. Okay. This is the gets function here. Okay. So in this gets function, RBP minus 0x20 is supposed to have our input. So we'll set a breakpoint after, let's say this, after calling the getters function. Okay. So B star is setting a breakpoint like this. B star. The address of this here. We copy this. We have copied this and we pasted it here. It's both the same. Into it. Yeah. Breakpoint is set. At this, we'll run the binary. It asks us for an input. let's say 5 A's. How many? 6 A's. Okay. Enter it. It hits the breakpoint, hits the place okay, where we had set the breakpoint before. And now let's check where our input is. Okay. So our input should be there in RBP minus 0x20. Then RDI. Okay. Okay. Yeah. Alright. Yeah, RBP minus 0x20 has that input. Okay, so what we can do with this red to win challenge here is, we don't have a variable as it was there on the last challenge, so we have a win function. Okay, so we would like to return to the win function when we have overflowed the stack. Let's overflow. Let's see how we can overflow the stack. Okay, run it again. Let's put unlimited number of A's, let's see, not A's, some B's, some C's, some D's, some E's, some F's. I think this should be enough. Let's see, let's continue.
Another factor you guys should consider is that it's a 64-bit. So whatever input that you're gonna give are being stored in the specific registers. So let's say you give like 5 inputs. So each, like, imagine it as variables. So each register would get stored in. So if there is like local variables, let's say 5 local variables are there, variable 1, 2, 3, and 4. So whatever input that you are given, it will be stored in that specific register. So right now over here, you just have to give one input, which is being stored in char buff. So that whatever input that you're going to give will be stored in EAX, the register EAX. So if you go to the terminal, just do /s $EAX.
$S $.
So right now it is 64. So RX.
Oh, it has to be run again. 4 A's. How many A's?
4 A's.
Okay. 4 A's. /s $RAX.
See, whatever input that you have given is right now being stored in RAX. So RX is so in 64-bit convention. So just imagine this. There are two conventions, as we said in Intel. So 32 and 64. In case of 64, whatever happens is that whatever input you are giving, all of it just gets stored into the stack, just directly kept into the stack. But what happens in 64-bit is that those inputs get stored into the registers, and those registers would contain that value. So let's say that you are giving too many variables with too many inputs, then first 6 of them would get stored into the registers, and afterwards it gets stored in the stack. So right now we just only have to give one input, so that has been stored into EAX.
So let's run the program again, and since our buff was 24 bytes, so let's try to input 25 bytes into this. Okay, let's see what happens. So 1, 2, 3, 4, 5, 6, 7, 24 and 25. Okay. So what it basically does is, it starts has filled the RSP. Okay, just a minute. RSP, yeah. The R10 gets filled with wait, just a minute, that's the problem. No, I removed the breakpoint from it. So what we can do is, we can put 25 A's here. Here. Some more A's that we want, and continue. After that, continuing, you can see that our RBP, once the program is fully finished, okay, but the RBP is getting overwritten by the ACE. Yeah, okay, overwritten by the ACE. Okay. So we are overwritten RBP, and after the RBP, just as we can see in the diagram here, there is RIP. So the value, the address which is there on the RIP is where we are gonna return to, and which is win here. Okay, win here. Okay. So, which is win here. So this as win. We have our execute thing here, from which we'll be accessing, we'll be gaining a shell from it. So this is a 64-bit binary. So you must be thinking how big would RBP be to override this? Okay, so RBP is nothing. We can, if we count this, it is 16 bytes. Okay, so what we do is to override. So there is our input buffer which was there. We can see here our input buffer of 24 bytes. Then we'll have to override the RBP, which is more of 16 bytes here. So the total junk input that we are supposed to give to this exploit would be, can you calculate? 24 plus 16. 24 is the buffer. 24 is the buffer. I'll repeat. 24 is the buffer plus 16, the RBP. Okay, just because it's a 64-bit binary, the address is this long. We'll have to override the whole address, and then only we will reach the address of the RIP. Okay, so let's see. We'll copy the info functions. Some unique stuff happened. Gdb. Info functions.
What happened is that if you do info functions after you have run the program, it gives you a lot more of functions, which is not something that you want.
So
refrain
we
from
will
doing
be
it.
taking the address of the win function here, because that's where we want to return to. Now the RIP starts from 24 bytes of our buffer plus 16 bytes of the RBP, the base pointer. We have to override the base pointer. Let's start writing the exploit. Okay. Nano again expp expp.py. Start writing. Again from on input star I1 is equals to process. Now we'll craft a payload. Okay. Payload is equals to bytes. We'll be giving A's as the bytes into 40. Why 40? Sorry. Why 40? 24 of buffer. Okay. It will reach the RBP, and once it reaches the RBP, 16 bytes, we have to override the RBP 16 bytes. Override RBP. Is that a cool dollar sign? Yeah. Then we'll add the address that we have. Okay. Win address of the win function, because that's where we want to return to. Now we have reached the RIP. The address that we'll be giving now is where the program will be returning after the exploit executes, after the exploit works. Plus is equals to add. We'll have to add, and since it's a 64-bit binary, Pawn Tools gives us the feature of not inputting it in a written format manually by just writing \x, this, that stuff. We can just add the address that we already had and already gained from the GDB and put it here. Okay. Send the payload with io.sendLine. Sendline payload. Okay. Then it's io.interactive, because we want our execute shell to be open so that we can play with it. Okay. So our exploit is over more or less. Let's try to run it and let's see if this is causing some errors or not. Okay. Control X to save the modified buffers. Yes. Enter. Python 3. exp. So the exploit is executed, and let's see if we have a shell or not. Yeah, we have a shell here. We can do a who am I. So yeah, I'm not the Night King, but my name is Night King here. And yeah, the shell gets executed. Now I want you all to ask if there are any doubts regarding this, how we had overwritten the buffer and why did we override the RBP and not do 24 plus the address of the win function. This is the address of the win function again. Any doubts? Plus, we'll be giving you a feedback form of how did you like, how well did you like our 2-day session of binary exploitation very soon. So, was this an InCTFj challenge? Whereas Misha, this wasn't an InCTFj challenge. This is a Tragoda challenge. So it should be there.
A demo reactor bot. So right now we have not planned one as such. So if you guys really need it, we would be doing maybe a video on how to do reactor bot. But that is basically a very, very high level concept of like literally overwriting the bot as such. So you guys should be learning all the things that you're supposed to learn until then in order to understand it. So maybe refer to BIOS roadmap in which you could see a lot of things that should be completed before overwriting of bot.
So Pehlaj asked, how did we get 16 plus 24? Okay. So I'll be explaining you with this very diagram. Imagine we have this passphrase and we want to write the RIP. So we'll override this passphrase with 20 bytes. And once this 20 bytes gets executed, we'll reach the RBP, we'll reach the level, okay. Forget the auth for now. So we'll start filling the stack from here. And after 20 bytes, after 24 bytes in that challenge, it will reach here, okay? But we want to control RIP, right? But between a buffer and RIP, there is another register here. Okay, there's another register which is the RBP. So we'll have to override this also. What is it? Prabhat. We'll have to override this also. So for overriding this, we'll have to input another 16 bytes so that we'll reach the stack till here, and we'll start overwriting RIP after that. Do you understand? Once we fill the buffer for 24 bytes till here, which is here, we'll have to overwrite the RBP because it's between our buffer and the array. We'll have to overwrite this also. Okay, So for overwriting this in 64-bit binary, we see addresses are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wow, that's 16 bits we have to override. That's why we are adding 16 to our buffer so that it overrides the RBP. So once the RBP gets overwritten, then only we can start writing our address on RIP. So then only we can do that. Is your doubt clear, Prabhat? If anyone has more doubts, please ask. Please ask. We'll be sharing the slides after the session. Definitely. So now we'll be providing you we have provided a feedback form link in the chat box. Please go and fill that. Please share your views on areas where we can improve. Okay. And tell us, how was it? How was the sessions? Please ask, can we do these commands in virtual desk? Yeah, we can do this command in virtual desk. Demo of returning to. The demo videos, the challenges which are already there will be uploaded as videos for you all. We'll try to do that, but we won't be doing that on this live stream. Okay. These all challenges are from Pagoda, and not from the challenges that you're supposed to do on your own. That is given to you. Okay. Feel free to ask any doubts in the InCTFj server. We are all there to help you all. Maybe we can reply a little bit late because we're busy with our own stuff, but we'll definitely reply. Okay. Please have patience and ask your doubts. Thank you very much again, everyone. Please go and fill up the feedback form that we have posted in the link, posted in the chat box, and tell us how we can improve. How was the session? How did you like it? Did you understand it? Did you understand all the stuff, or did you understand? Did you miss out on something? Just tell us. Thanks, Listen Media.
Yeah, so today was the last session which we will be taking. So for people who still have doubts in any of the category, we have our server active all the time. So the invite links are there in the description of this video. You guys join that and ask your doubts there. It will definitely be cleared. And yeah, fill out the feedback form they just gave. I've pinned it in the chat if you have lost any. And yeah, before we move in this live session, I would once again like to thank our sponsors, our event sponsor Salesforce, our diamond sponsor Zoho and VMware, our platinum sponsor CrowdStrike, our gold sponsor Cred, and our silver sponsors Jnanamurga Technologies and HNR Block for the help and support in making this possible. Yeah, so this is it from our side in the training. Yeah, hope to see your doubts in the channel.